All right, let's go ahead and get started. Obviously, I'm not in the room, and somebody is in the room. So whenever I ask you to show your hands or see how people are doing, he's going to write it down so I can view the lesson and see if it was a success or not. I do have a brain break planned, so first time I've ever tried to do one of those remotely. We'll see how that goes. But for right now, this is the last section in the chapter, variation. And it's obviously, or it's also one of the easiest sections that we've got. So variation. Usually there's two types of variation, directly and indirectly. Um, some people will say directly and indirectly, proportionally, inversely. Inverse is another word. Proportional is another word. So, but you get the idea that there's a couple ways variation works. And the main idea is that as y changes, x is changing by multiplying some constant if it's a direct. If it's an inverse, well then you're still multiplying by k, but x becomes 1 over x. That's the whole basic idea between variation. How is y changing as x changes? Usually x is always increasing on a graph. If you look at a graph from x and y, usually x is always increasing. What's y doing? Is y getting bigger as you go, or is y getting smaller as it goes? One's an inverse relation and one's a direct variation. So that's what the word variation means. Try to get through as much as I can. Answer any questions on your homework tomorrow. We still have then we talk about your tests when we get back. I'll talk about your tests when we get back. A couple days review, and we'll move on. So let's get to some examples. You can open your books, follow along. Terminology is just as I said. That's in your textbook. Y varies directly as x equals y equals kx. Another key word I said was proportional to x. This is the main idea. Y equals kx. K is your slope. K is the slope of your line. And there is no, I repeat, no y-intercept. There's no y-intercept. Okay? So that's just the equation of a line. You can see there's an example in your textbook. As x increases, y increases. As y decreases, x decreases. We had a show that one time where we had, well, let me go back up in case you want to write that down. I forget, I'm going pretty fast. We had a show that one time for an increasing function. It was increasing if the first x was smaller than the second x. Well, I'll just call this one, I'll just call this one x1 and this one x2. And we said for increasing, if it was increasing, we said f of x sub 1 was smaller than f of x sub 2. Well, take a look at the y value. Here's f of x sub 1. And here is f of x sub 2. This is an algebraic way of showing how something is increasing. For your constant of variation, you have to be given some numbers, work it out, and usually in a variation problem you want to solve for k. Okay? Usually you want to solve for k. So, you get the idea. I can find the variation between those 2 points, figure out what k equals, and I can move on. All right? So that's a variation. Much in the same vein, as y varies inversely, or indirectly, I also said, it's also inversely proportional to x. I'll give you a minute to jot that down again, those that didn't do it. Obviously, this is the big one that you're going to multiply by and, things like that. So I'll give you a minute. All right. On this graph, we also had the algebra, as x increases, y decreases. We had the algebra from that show that in this section. If x sub 1 was less than x sub 2, so I'm going to choose this as x sub 1, I'm going to choose this as x sub 2. Then we said if f of x is decreasing, we said that f of x sub 1 is bigger than f of x sub 2. That's the y value. Here you go. F of x sub 1. Here you go. F of x sub 2. All right? So that's pretty good. You got the idea about how that works. And go ahead and jot that down. We'll do a few examples. And I'm still a little nervous about doing the brain break, but we'll give it a shot. Okay. Ready? Okay, this shows that f of x decreases. All right, we got that. All right, here's the guidelines for the variation. These are in your textbook. I wouldn't write this all down. You can find these in your textbook. They're listed on page 269, I believe, if you have it. That sounds right to me. Anyway, write the general formula that involves k. You're going to have a y equals kx or something like that. Then you're going to find the value of k. So k equals something. Using a little algebra. Rewrite your equation as y equals something times x. And you're going to use that to solve a problem. It's really pretty basic. If you want a complete set of notes on there, then go ahead and, make sure you go to page 269 and jot these things down. But that's basically what we're going to do. Find the value of k using the initial data. Rewrite your equation. Then use the new data to solve a problem. Sometimes you won't use this. Sometimes you'll stop right here at, k equals. It just all depends. All right? So, we're moving on. I'm not sure which one this one is. It's probably in your book. S varies directly as t, if t is 10 and s is 18. This is on page 272. This is actually problem number 2. If you can't see the board and you want to jot down and follow along. The directions say express the statement as a formula that involves the given variables and a constant of k. Then determine the value of k from the given conditions. So, here's our initial statement. S varies directly with t. That's first. Second, you put the numbers in. 18 equals 10 k times 10. Very good. Whew, that was close. So after that, you have k equals 18 over 10. So, k is going to equal 1.8. I think 18 divided by 10, 1.8, sounds good to me. And then third, you write your equation. S equals, if you want to get fancy, you could write down 9/5 k, or t if you want. Obviously, that's the same thing as 9 over 5. Okay? And that's it. That's not that difficult. In fact, I don't even think we need a brain break for this today. But, I want to try it remotely and see how it works. All right? So that's how you do, a constant variation problem. Sounds a lot worse than it really is, actually. All right, we're moving on. Oh, we're not ready for this yet. Let me move that down. Oh, we barely got started. Move that down. There we go. Yeah, that's the brain break. Looks pretty cool, doesn't it? All right. Express the statement as a formula that involves the given variables. And constant term, then determine the value of k from the given conditions. Sounds good to me. Q is inversely proportional to the sum of x and y. Q is inversely proportional to the sum of x and y. I believe this is number 6 on page 272. All right, so Q equals K times 1 over x plus y. That doesn't look too difficult. That's the first step. Just get your facts straight, figure out where to put the numbers. And now we're going to move on and put some numbers in. 1.4 equals K, we're going to solve for K, 1 over 0.5 plus 0.7. So 1.4 equals K times 1 over 1.2. Or 1.4 equals K over 1.2. Let's see, 1.4 times 1.2. I'll go ahead and get the calculator. Maybe. I might need it anyway. There we go. All right. So I'll take second and quit. I'll take 1.4 times 1.2. K equals 1.68. So this is statement, this is number 2. Number 3 is Q equals 1.68 times 1 over x plus y. Or you could have Q equals 1.68 over x plus y. Sounds good to me. If I made a mistake, let me know about that later, but it looks pretty good to me. X, Y, and Q. Now, if you want, they could have you solve some problems with that, and you know, you can do some work that way. But other than that, I think we're in pretty good shape. All right, moving on. Here's another one. It's got a lot of things going on. Let's give it a shot. Express a statement and then determine the value of K from the given conditions. Y is directly proportional to X. Y equals K times X, and inversely proportional to the sum of R and S. You don't need 2 K's in the problem. 1 K does it both. So it has the word and in it, so you know it's at the same time. And you just write it as you read it. Y is directly proportional to X, and then inversely proportional to the sum of R and S. All right? Now, the only tough thing about this is your algebra. Putting the 2 in for Y, got the K, solving for the K, you got the 3, got the 1 over 5 plus 7. Should be too difficult. 2 equals K times, I don't know, that's 12, 1/4, I think, which tells you that K equals 8. All right, so my final answer is going to be Y equals 8x over R plus S. I just shortened it up a bit. Okay, just shorten it up a little bit. I didn't put 8x times 1 over R plus S. I just put 8x over R plus S. Okay, any questions on that? I believe that question was number 10. Okay, I believe that one was number 10. All right, getting closer to the brain break. Not quite yet, though. We've only been in class 15 minutes. Got another about 5 or 10 minutes to go. Oh, got to move it. We got to get to Hooke's Law first. There we go. Let's do another one. In fact, why don't you give this one a go? Oh, this is Hooke's Law. All right, so after Hooke's Law, we'll do our brain break after part A. Hooke's Law states that the force required to stretch a spring X units beyond its natural length is directly proportional to x. Force F required to stretch a spring x units beyond its natural length is directly proportional to x. I didn't look too hard. F equals k times x. All right. A. Express f as a function of x by means of the formula that involves a constant. Oh, a function. That means f of x equals k times x. That's pretty good. I like that. Sounds good to me. All right. Let's see, the solution for part A was f of x equals k times x. The weight, 4 pounds, stretches a certain spring from its natural length of 10 inches to the length of 10.3 inches. Find the value of k. All right. Shouldn't be too difficult. We all know that x is the length. X is the units beyond its natural length. That's what x is. So in this case, x is going to be 0.3. Here's k. We also know from Mr. Glaser in physics that force, F, is the same as the weight, W, of 4 pounds. That is the force. So that equals 4. So that means that k equals 4 divided by 0.3. So k equals 13 1/3. Sounds good to me. Sound good to anybody else? Fantastic. All right. So that's my answer. F of x equals 13 1/3 times x. 39 or 40/3, whatever you want to do. Does that sound right to you? I don't know. We'll go on and figure it out. Okay, after this we'll do, let's do one or two more, and then we got finish out Cook's Law, then we'll do it. All right, so this one was f of x equals kx. This one was f of x equals 13 1/3 times x. What weight will stretch the spring, this is the weight, in part A to a length of 11.5 inches? Well, you don't put in 11.5 inches. Remember, we started at 10. You're stretching all the way to 11.5, so that's a difference of 1.5 inches. So, f of x equals, let's see, 13 1/3 times 1.5. Well, that's not too bad. When you do a mixed number on the calculator, actually I don't do mixed number, I can just do this number. I just put times 1.5. 20. That sounds about right. F of x equals 20 pounds. That's not too bad at all. All right, is this still with Hooke's Law? Oh my gosh. Sketch a graph of the relationship between f of x for x greater than or equals 0. Here is f of x equals kx. Here is f of x equals 13 1/3 x. Well, sketch a graph. That's easy. The slope's 13 1/3, so if I go over 1, I'm going to go up 13 1/3. It's going to be a pretty steep graph. So that's going to look like that. It looks like a ray, actually. Okay? Very good. Now we're moving on. Oh, brain break. All right, on this one, it's called paper twirling. Don't get up yet. You'll make whoever's in my place nervous. They don't know what's going on. They're scared to death the way it is. So this activity forces you to move a piece of paper around your waist without grabbing it. Without grabbing it. The brain break police will be watching you. It says you can use a spiral notebook. So find a piece of paper. Don't stand up yet. Let's read through this and then stand up. Find a piece of paper and stand up. Put your right hand out with your palm up. So there you are, standing right there. Right hand out, palm up. Holding, don't grab the paper. Put the paper on the top of your hand. I did that. Don't grab it, just hold it. Keep the paper at a level height and move it around your waist. Move it around your waist, going backwards or forwards. And transfer the paper to the other hand. You can only drop the paper onto the other hand. You may not grab the paper. You might have to contort your body so you can make the transfer, as is being shown in this picture. Keep it at a level height. Continue to keep the paper level, move it in front of you. This is one round. So you're going to go around yourself 3 times, 3 rounds, and then switch directions and go 3 more rounds the other way, this way. Try to do this as fast as possible. All right, go ahead and stand up. Try not to make the person in the room, in my place, nervous. All right, get your piece of paper, give yourself some room, and start the brain break now, please, by passing the paper around your body, handing it off, trying to go 3 times. I am doing quite well, actually. I'm doing better than you guys. Yes, I'm actually doing it. Oh, pick the paper up. All right, going around. 1, 2, good. And then go back around the other way 3 times. Pick the paper up. Keep it level. Shift it from one to the other. All right. You should be about done. Once you're done, have a seat. And I'm moving on in about, 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Done. All right. Go ahead and have a seat. Hopefully it went well. You can tell me tomorrow how it went. My first brain break without me there. Interesting. We'll see how it went. All right. We're back on page 272. Okay. This one is question number 20. The range of a projectile. All right, we're almost done. We've only been out for about 25 minutes, so we got a few minutes left, about halfway through the period. We'll probably do one more example and see how we end up. I got, 3 or 4, we'll see. Okay? I still have to answer questions tomorrow in your homework from Friday. So express, it is known from physics, the range R of a projectile is directly proportional to the square of the velocity v. Express R as a function of v. Before I get to A, R is directly proportional to the square of v. R equals kv squared. Express R as a function of v by means of a formula that involves a constant proportion. So, I changed my equation. How do I change it to a function? Easy. It says R is a function of v. kv squared. That wasn't too difficult. Again, this is number 20 on page 273. Right? So, with that said, we said R equals, we said that R of V equaled kV squared. Okay. A motorcycle has made a jump of 150 feet. Okay. If the speed coming off the ramp was 70 miles per hour, find the value of K in part A. Well, I think the 150 goes in for R, and I think the 70 goes in for B. So 150 equals KB squared. Well, that means that K equals 150 over 70 squared. Does that sound right? All right, punch it out. See if you get the same thing I do. I don't want you getting wrong on 10 for 10 in case I make a mistake. 150 divided by 70 squared. Ooh, does that fractionalize? Yes, it does. 398. So we'll use that one. So that means my equation is R of V equals 398 V squared. Pretty sweet, if you ask me. All right. RV equals 398 V squared. So this one was R of V equals KB squared. This one was R of V for 398 V squared. All right, you don't have to write those down over, but you just have to bring them up. If the Daredevil can reach a speed of 80 coming off the ramp and maintain proper balance, estimate the possible length of the jump. Well, shoot, I think you can just put that in your calculator, can't you? R of 80 equals 398 of 80 squared. Three divided by, oh, I already got it up there. Oh, shoot. Second and enter. There we go, 398 times 80 squared. 195.9 feet. Does that sound right to anybody? I don't know. Is that very far? I don't know if it is or not. 195.9 feet. Good. All right. That takes me into about 30 minutes, I believe. Let's see what we got left. Fantastic. We'll probably do one more. Yeah, we'll probably do one more. Yeah. We'll do one more, and that'll take us into Tuesday where I can answer homework questions. All right? So, this will be the last one. Express V. Volume of the gas occupied. This one is number, let's see, 24. Okay? The ideal gas law states that the volume V the gas occupies is directly proportional number of N moles of a gas. The ideal gas law states that volume V is directly proportional to the number of moles of gas and the temperature K, and inversely proportional to the pressure. Does that sound right? Directly proportional to N and T, inversely proportional to P. I don't know, sounds pretty good to me. We got moles, that sounds like chemistry, temperature and Kelvin, I think. And atmospheres, that's pressure. Yeah, sounds good. So V equals K N T over P. If you know a lot about science and you know a lot, that's probably right. What is the effect on the volume if the number of moles is doubled? K times 2N doubled, and both the temperature and pressure are reduced by a factor of a half, P over 2. What is that effect? Well, I don't know. Well, Now, what is the effect on the volume if the number of moles is doubled? Did that. Check. And both the temperature and pressure are reduced by 1/2. Check on that too. Well, that means that V equals KNT over P over 2, right? Well, I'll have to sledge this out. If you hear that bell, that's not yours. That's mine. The 2's will drop down here. I'm sledging it out. So V equals 2 times KNT over P. Looks to me like the volume is doubled. You'll double whatever volume you'll have. So the volume is doubled. Sounds good to me. All right, that was my last example. There's a reason for that. For homework, I want you to start working on page 272. I don't know, you got 1 through 25 odd. That's not that difficult. You can do that. Tomorrow, we've got shortened periods. I got to get a 5 for 10 in. I got to answer questions on the homework from 2 sections. And 7th hour has like 20 minutes. So, it's going to be picking them up and putting them down tomorrow. Get your homework done. The 5 for 10, that'll come out of the rational algebraic section. How to graph those things out, sketching the graphs. So you should be in pretty good shape. Anyway, hopefully, I don't know, you still have about 10, 15 minutes left. I don't know, about 15. I know you got at least 10. So get started. If you got questions, we'll get them taken care of tomorrow. 5 for 10. Two sections on questions. So, hope you enjoyed the brain break. Hope you had a good day. Let me know about any problems for tomorrow. Thanks. See ya.